Hello there, welcome to my question of the day, and this is number 21 in a series that I've been running most weekdays on my Facebook page. So my question today is taken from a really nice little exam practice workbook published by CGP, who makes some really great books. It's targeted particularly at grade 9, so anyone doing higher level GCSE, anyone starting AS and wants to get a bit better at SERDs, this is a kind of question for you. So I've got to write that expression in the form a root b, where a and b are integers. And if you don't know what an integer is, they are just like whole numbers, but they also include negatives as well. So any of those whole numbers, including 0, and they can be positive or negative. So I've got to write root 343, probably in a different way. So I think what I'm going to do is I'm going to take each of these expressions and I'm going to simplify them before I pop them all together. So I've got to write 343 in a different way. So I've got to simplify that SERD. I've also got 21 over root 7 to deal with. And I've also got 4 lots of root 252 to deal with. So each of these I'm going to deal with just down here. I'm going to colour code them so I remember what I'm actually going to be doing with them. Okay. So there are 3 expressions there. Right, so 343. Now I happen to know that 343 is 7 cubed. So I believe that 7 lots of 49 is 343. That's really useful because of course 49 is a square number. So if I do the square root of 49 times 7, that's the square root of 49, multiplied by the square root of 7. Now my laws of logs, my laws of SERDs, sorry. When I have a product inside a SERD, I can just split it up into those separate components. So I know that root 343 is the same as 7 root 7. So I've got that as my simplified expression there. Now, when I look at 21 over root 7, I can see that my denominator is not a rational number. Therefore, what I'm going to do is I'm going to do a little trick, which is called rationalising the denominator. And I'm just going to multiply by root 7 over root 7. And if I do that, I end up getting 21 lots of root 7 on the numerator and 7 on the denominator. And if I simplify that, I get 3 root 7. So that's a simplified form of 21 over root 7. Now for 252 inside my square root, I think I'm going to have to look for some factors there because I don't recognise 252 as having any square factors. So I think what I'm going to do is break it down into some prime factors because I really love prime factors. So if I cut that in half, I get 126. And I know that 2 is a prime number. And if I cut 126 in half as well, I get 63. And actually that's quite nice because I know that 63 is 9 times 7. And because I'm looking for square factors when I'm simplifying a SERD, 9 is really nice there. So if I know that 252 is 2 times 2 times 9 times 7, I also know that it's 4 times 9 times 7. And having those square numbers is really useful. I can multiply those together to get a bigger square number if I want to. Lovely. So 4 lots of root 252 is 4 lots of, and in my bracket I'm going to write 36 multiplied by 7. That gives me 4 lots of root 36 multiplied by root 7, which gives me 4 lots of 6 lots of root 7, which simplifies to 24 root 7. So those 3 gave me answers in terms of root 7, which is really good. Now, I can see the question up here said that I had to write root 343 and 21 over root 7, subtract 4 lots of root 252, and I had to express it so that it was identical to the form a root b. So all I'm going to do now is substitute my values for each one of those simplified expressions. And that's got to be equivalent to a root b. So I have 10 root 7, subtract 24 root 7. and therefore that gives me negative 14 lots of root 7, which is in the form a root b, and I can conclude that a must be negative 14, and whoops, put that b inside that root there, and b is 7. So they are my answers, but really the answer that I was looking for was, let's pop it in yellow there, negative 14 root 7. Okay, thank you very much.